So now we're going to take a look at the single phase full wave rectifier. So in this video, we're going to be looking at the positive as well as the negative sections of the wave. We're going to be in the same time period, so 0, pi to 2 pi. We're going to be using peak voltage in this problem as well, and we're going to solve for the area under the positive curve as well as the area under the negative curve. And just like in the last problem, we're going to be solving for Vmax so that we can place any Vmax into the problem and get our VDC out. So the formula for a full wave rectifier VDC out, 1 over 2 pi times the integral of Vmax times sine theta. And once again, we're going to be looking between 0 and pi minus the integral Vmax times sine theta, but this time it's between pi and 2 pi. Now the reason we have the two integrations is because we're not only looking at the positive section of the sine wave, we're also looking at the negative section of the sine wave. And you may be thinking, well, why are we subtracting? Why are we just not adding the second portion of it? Well, like you probably remember, the math is going to solve itself. So we are adding it, but we're adding the negative portion, hence the subtraction portion. Again, like we all know, math will solve itself. So just like last time, we're going to be looking for the areas under the curves or within the curves, then divide the area by the period. So let's start by focusing on the integration portion of the formula. And we'll just take it step by step. So the integration 0 to pi, well, we already found that in the last video. So let's just bring that down, and half of this problem is already done. So we found that the positive portion of the sine wave is 1 over 2 pi times 2 times Vmax. So now we can focus on the second integration, which is between pi and 2 pi. Now remember, we're subtracting this integration, so we want to bring down that negative. And the way that I do it, I just bring it down and put it outside of the parentheses just to keep myself organized. So once again, we're going to bring the 1 over 2 pi down minus the quantity Vmax times negative cosine 2 pi minus Vmax times negative cosine pi. So we can simplify this. We can pull out the Vmax and rewrite it. Then we get 1 over 2 pi times negative quantity negative cosine 2 pi plus cosine pi times Vmax. Now we can go ahead and distribute this negative that we brought down and rewrite it. So now we get 1 over 2 pi times the quantity cosine 2 pi minus cosine pi times Vmax. At this point, we can go ahead and just solve for the cosine 2 pi as well as the cosine pi. Now again, we're dealing in radians, so if your calculator is set to degrees, it's not going to work, so we want to make sure that we're in radians. So after rewriting, we get 1 over 2 pi times the quantity of 1 plus 1 times Vmax. So simplifying, we get 1 over 2 pi times the quantity 2 times Vmax. So now we have the solutions for the area between 0 and pi, as well as the area between pi and 2 pi. Now we can solve for the VDC out. So VDC out is equal to 1 over 2 pi times 2 times Vmax plus 1 over 2 pi times 2 times Vmax. Do you see how we didn't have to force the addition of the second area? The math just did it for us. So we can simplify this and we get 1 over 2 pi times Vmax times 2 plus 2. All we did here was pull out a 1 over 2 pi and a Vmax from each side, leaving us with 2 plus 2. Now we can further simplify this, leaving us with 4 over 2 pi times Vmax, and giving us a final solution of VDC out is equal to 0.637 times Vmax. So you can see how having the basics down and breaking things down to a simplistic form and taking things step by step, it helps give you the tools to be able to attack the, I hate to say more complicated problems because they're not overly complicated, but having those tools helps you to go from a single phase half wave rectifier to a single phase full wave rectifier. And the principles are the same. The math is basically the same. It's just watching your symbols. And if you go step by step, the math will show it all to you. Remember to always check your calculator or that you're in radians and you're calculating for radians, and you will be good to go.